Hello and welcome everyone. We are going to be starting now. So for the people that are outside or they are a little bit on the back of the room, please come forward. We want to make this session as interactive as possible. Okay? Welcome everyone. So today's session is going to be mainly on how to help you guys to reduce your cycle time. Lots of people have been talking in this conference about cycle time end-to-end from when you start on your requirements until you deploy to your target environment. And instead of just telling you another essay story how you should do, we brought you a client. So we are Gary Forge and we work with large clients, and I will leave the word to Fabio to present who they are.
Hi everybody, I'm Fabio Ponceroli. I'm a software developer, plus I do some operation in my team, hence I'm probably a DevOps. I work for Yux Net-a-Porter Group, which is the leading online luxury retail company. Some number about Yux Net-a-Porter you can see here. We are about just under 1,000 developers. Located in Italy and UK mainly.
And just about us, Gary Forge, for the people that do not know who we are. So we are a company that is based on open source. We have been contributed to Jenkins for, I would say, over 10 years so far. And we are the company that is investing a lot in Git code review. That is a code review system based on Git that allows you to work effectively between your team and different teams. And here we are going to show you how we use some big data technologies in order to reduce the cycle time of a user. And those guys, they've achieved wonderful results, I would say.
So briefly, the agenda of this presentation. So we're going to introduce you the insane idea that we had, which is the reason why we are here. We're going to show you a demo with a case study that we did in Yux Net-a-Porter, just to demonstrate that what we did is not just a prototype, but it's something that we use in real life. We're going to go through the problems that we try to resolve. We're going to show you the architecture of our implementation. And we're going to explain you the concept of what we call central and local pipeline. Another interesting concept, which is the just-in-time UAT. An example of how the central and local pipeline can cooperate. And one of the other benefits that we had was like putting together the code and the pipeline definition, not only in the same repository, but in the same branch. And then a QA session at the end.
Okay, so let's start with the problems they had and the crazy idea we had as a result of those problems. So the problems was the same problems that you guys have. You want to go faster. But faster not just in the build time, because I saw people that were saying, yeah, we went for 1 hour build time to 5 minutes build time. Come on, that's not the full story. There is people that need time to get this build and deploy somewhere. And even if you do automatically, there is people that need to start to test this build that is somewhere. And then there is even the other side. So whenever you need to go and start developing something, you need to interact with the product owner. And you need to show the product owner something that you have done. And as soon as you start these early, you can save time. So those guys that were starting from cycle time that was taking, I would say, weeks, and the build time roughly was taking over an hour. So we say, okay, let's start analyzing where are the bottlenecks. And we saw the bottlenecks and we say, oh my gosh, but the server itself is very much collapsed, and then there is a lot of lead time that we are losing because we need to go and we can't use certain plugins, and the server itself maybe takes a very long time to go to an environment that the product owner can see. So why don't we reuse our laptops and our local environment to run Jenkins on top of it? Oh, some people say that sounds crazy.
But that's what basically that's what we did. So we thought, okay, so nowadays we have such powerful machine. Why not leveraging this machine? So for example, I quite like the tagline of the last Macintosh. It's not a typo. It's not a typo because this machine has 18 cores in it. So in your laptop, you have 18 cores, and it's actually not a typo. So it's such a powerful machine. Why not using this power?
Okay, so you guys will say, come on, Luca, what are you telling me? This is what the early days. Everyone was running Jenkins on their local machine. How many of you have done it? Raise your hand, raise your hand. There we go. Say, don't tell me. That's nothing new, right? So, and whatever the build breaks, what's the usual answer from developers? Works on my local machine. So I say, come on, that's cannot be the solution, right?
So here what we thought about, we thought like, okay, let's have like a classical central pipeline with a Git server, with Jenkins, of course, and Docker. And then let's have some what we call local pipeline on each developer machine with Git and Jenkins running on the machine of each developer. And these two local and central pipeline, they communicate between each other, as we're going to show now.
Okay, just to focus, so what is different from the early days where you were running everything locally on your laptop? That you actually don't do all the steps of the pipeline. So imagine your pipeline has many steps, right? Some of them, does it really make sense to run on the server? So if you manage to replicate and Dockerize the entire infrastructure of Jenkins, including plugins, including everything, you can break down your pipeline in stages, and some of the stages running on different machines. And the two pipelines, they cooperate together. So it means that whenever the local pipeline is finished, we'll push to the server one. And on the other way back, whenever you have a failure, you can avoid going and using CPU and cycle time on the server, and you can reuse some early results to share with your people. Okay, so in order to understand exactly how it works, what's the best way? Show it to you.
So demo time. So we're going to show you an example of these two entities, the local and the central pipeline cooperating between each other. So this demo is an extract of what we use in production in Yux and Net-a-Porter. You're going to see the pipeline with the red background is the local pipeline.
That is running here on this laptop, really. So if there is any fault, I'm sorry, that's my laptop.
And then the one with the green background, which is a central pipeline, so which is located on a central server. And we have a really simple application running in Heroku.
This is horrible
really
red.
And now what we're going to do, we're going to create a branch on Luca's laptop, where we're going to change the background to be green. Really complicated.
That's a very difficult task, man. So if I made it wrong, I'm sorry, that was too difficult for me.
So what we're going to do, we're going to break on purpose the build initially.
Let's have a look if I can break the build. Yeah,
so we will show you that
went out this one.
When the build is broken, we're not gonna affect the central pipeline. So the idea is that only when a build is successful on the local pipeline, the code will be committed to the central one. So what we are doing, we are creating a sort of back pressure on the central server, and we are just getting to the central server whenever it's needed, whenever we are confident that a build will be successful. So what we are doing, we are not putting so much pressure on the central server. So as you can see, Jenkins on Luca's laptop picked up the change.
I haven't pushed anything. So it's been picked up as soon as I create a local commit. That's very important because that's early feedback.
Yeah, so you don't need to do anything. You don't even have to remember to commit it. So it can be quicker than that, the feedback. So now we are building the branch on the pipeline. As you can see, the build is broken.
Yeah, one thing to notice is that the central is not doing anything. So I haven't lost any CPU cycles on the server.
Exactly. So the central pipeline is totally idle. So now we're going to fix it. We're going to fix the local pipeline. We're going to change the background. And we're going to show you that actually the last step of the local pipeline is the push to, in this case, we are using GitHub, which is our Git server. So now Luca is changing the background color somewhere.
I know this one.
If you look up for red.
And that's a difficult task. There we go. Let's make it green. Yeah.
We're going to change the background to green. And there you go. So now the local, yeah. Again, Luca didn't push anything, and now we should see the branch building again in the local pipeline. There you go. So now, once the build will be finished, we will see that actually the local pipeline will push the code to the central one. Hence, we will trigger the build on the central pipeline, and we will also create a pull request on GitHub, and once the pull request will be merged, again, the code will be deployed to our Heroku instance.
Yeah, I wanted to mention one thing. So you see this step is the push. So running a local pipeline not just makes your server life easier because the steps you have done locally, they've been done. They don't have to be done again on the server. But it's giving you the assurance that you're going to push to the central pipeline only if things are good. So the reduction of the broken builds on the central server is huge. So the central server was going much faster for all the other people because we're just spending less time in broken builds. And at the same time, the people that were breaking the code, they had the breakage not anymore in maybe half an hour or 40 minutes or 1 hour, but they had the feedback in 2 minutes, 3 minutes. And even before they were even thinking about creating a pull request. As you have noticed, we haven't created any pull requests at all on the server, and we've got already feedback. So whenever you integrate, for instance, GitHub with the Jenkins, and you start getting the feedback when you got a pull request, it's too late. You need the feedback when the developer writes the code, when you make the mistake, straight away. Another thing that is important, if you may say to the people, just do a local build. But when you do a local build, your environment is locked. You can't do anything else. But this guy works in background. So it means when he's building, I can start doing my next commit. I can start thinking about something else. Yeah? And there is another byproduct that Ponch is going to show you now that is really amazing. I like it a lot.
Yeah, this is definitely one of my
this guy,
feature.
Explain to the guy what is this stuff.
Well, we call it the just-in-time UAT. So imagine the application we've been working on is pretty much a front-end application. And we need to have lots of back and forth with our product owner. And this is a super nice way to show really early in the development life cycle what we've been working on. So let's say, for example, if Luca can show you, there you go. We have a Docker instance with our application running in our local environment, so on our laptop. That way you can show, for example, your product owner what you've been working on even before deploying your application to, let's say, a shared environment that you might have downstream for UAT or whatever. So you can have a really early feedback in the life cycle of your software development.
So now you've seen that as the local pipeline was building, okay, now it's being pushed to the central pipeline. So we finally have a feature branch on the server, and we are ready to go to, sorry, this one you see, the deployment is still red. And we can go and create a fantastic pull request. There we go. That's it. Comment. Sorry, I didn't want to comment.
The other advantage of having this just-in-time UAT is that sometimes you have dev environment or UAT environment which are shared among different teams, or they're used for integration of different applications. So it's always difficult to find a slot where you can test your stuff, or your product owner again can go and look at your stuff. But in this way, again, we are resolving this issue with the just-in-time UAT feature.
Yeah, another thing I have to mention, so we work with many clients, Houston at Porter, but many other large clients here are all distributed across the globe. And those guys are distributed as well. They've got places in New York, they're in Far East, and so on. And sometimes, I know, someone is pushing even some battery files into the repo. Who has done it? Sometimes, I know you've done it. Yeah, some jar files inside, specifically the people that are coming from Subversion. And we hear from clients sometimes that they've got pushes that last even for half an hour. Okay, do you really want the developer to be stuck for that after an hour? Do you really want that after an hour to impact your feedback? No. So you want to have your feedback straight away. And then all the rest of the pipeline, then you're very confident that will continue. And may fail for other reasons, maybe some integration with other systems, but at least you have reduced your probability of failure by maybe 50 or 60 or 70%. Okay, so now we know that he's finally merged to master, so this will do his job, will do all this final deployment, and finally now he's deploying to the target environment. So if you use AWS, for instance, you know that if you do immutable deployments in AWS, it might take even 15 minutes. It is something you can't do anything about it, right? Because you need to do the blue-green deployment, you need to start the new instances, shutting down the others, takes time. So you want to spend that time only when it is absolutely needed. And you don't want to waste any of those cycles.
Something that you might have noticed is that the steps in the central pipeline and the steps in the local pipeline are different. And that's another beauty of this solution, because you can have the flexibility of having different steps and customize your local pipeline as much as you want. Because, for example, you don't have to do everything you do on your local pipeline in your central pipeline, and vice versa. Maybe on your central pipeline, you want to run some more lengthy integration tests with other systems, which you don't need in your local pipeline.
There we go. Let's have a look if that works.
So now it should be green.
Hold on,
hopefully.
Mr. Hiroku. Wake up, wake up. This is real. If it would have taken just a few seconds, it was fake. It would have been fake, but that's real. So there we go. Done it. Mission accomplished. Okay, so let's go back to the slides. Okay, so what are the problems that we have resolved with this type of approach? So first of all, again, we took these type of approach just because based on the metrics, there were not just build metrics, but human metrics as well. Where do you really spend a lot of time? And we did it by extracting information from the system. We saw that, oh my gosh, most of the time is waited for the product owner to have a look what I've got. And if I can book his time early on, I can get it much better, much faster. But another one was even the repeatability. So we wanted the local pipeline and the central pipeline to be able to execute exactly the same step, exactly in the same way. And the way that we did it is to Dockerize everything, absolutely everything, from the slaves, from the master, and everything defined and version controlled, and being able to spin it wherever you want.
Another issue that we resolved was strategical issues. So Hughes, Net-a-Porter, they used to be two companies that at some point they merged in a unique company. And so we had this transition problem period where we needed to decide which tools to use. So both companies, they have their own, for example, CI/CD tools. We were doing stuff in a different way. So we needed to unify it. So there was a transition period where there were this discussion going on between the two companies, and but at the same time we needed to deliver some software. So we thought, okay, well, what are we going to do? We can't wait until we have a CI/CD in place. So that's why we started thinking about this concept of local pipeline. So we had a local pipeline where we can deploy, and we thought, okay, whenever the central pipeline will be ready, that's it. We're just going to integrate with it, we're going to push to it, etc.
And then again, as I said, we are developers as well. So we wanted fast feedback. And for us, 20 minutes, 10 minutes is too slow. We wanted feedback as soon as we code. And you know, the idea is they give you a feedback, but it's not exactly a full end-to-end feedback. Just that unified and repeatable build can give you the feedback you need.
That's another problem that we try to resolve. Something I mentioned before is the flexibility that having a local pipeline gives you. So you have the flexibility of customize your local pipeline as much as you want. For example, in our case, we added this feature of just-in-time UAT. Or for example, if you want to use a particular plugin on your local pipeline, that's it, you can do it. You don't have to refer to you know, the CI/CD team. That, of course, it's kind of a complicated situation, you know, running a master that can suit all the need of all the teams and all the developers. So having a local pipeline gives you this flexibility. You can customize it as much as you want because it's yours. It belongs to you and to your team. You don't have to rely on other teams.
Yeah, and that's a very good, important point. So how many times happened to you that you had a central Jenkins server in your team and one part of the team was once plugin A, they would say, oh my gosh, I can't do my job if you don't install my super duper plugin A. And the other part of the team is say, oh my gosh, I want plugin B. But hold on, the developer of plugin A didn't thought about the fact that there was plugin B as well. They want exactly the same dependency of different versions. And what happens? Raise your hand. What happens if you do that? Yeah, exactly. You can't do it. And if you do it, there is this fantastic butler that is burning fire. So because of that, the CI/CD team, they become so conservative about plugins. Whenever you ask for a plugin, it seems like going to the smuggler and ask for double. So can I get the Docker plugin? And say, oh my gosh, why do you really need it? So, and that's wrong, right? Because if for doing my job, I need plugin A, and I can make my work so much faster with plugin A. Why can't I do it? And the solution that we thought about with the local pipeline, we are going to show you in practice how it works, allow two different teams to work on the same central server, central pipeline, and have all the plugins they want. And they don't have to ask anyone. They just do it. Yeah, maybe let's show the Jenkinsfile. It's going to be really interesting because slides are always boring. I don't know about you, but I don't like them. So basically, if you go here, so that's the sample app. So you say, Luca, how can I put two Jenkinsfile in a project? Because the same project needs to be executed locally and centrally, but the Jenkinsfile is one. Okay, so let's have a look. That's the way we did. So let me increase the font. Okay, so the trick is this one. So this one, first of all, is a scripted pipeline. It's not declarative pipeline because Jenkins doesn't have support for that in a declarative pipeline. So what you do basically, you just ask, you have the main Jenkins file that the only thing it needs to do is to understand if I'm running in the context of a local pipeline or running in the context of a central pipeline. If it is the central, I load central Jenkins file. If it is local, I load local Jenkins file. Okay? So far, so good. It's not difficult.
A simple trick.
And if I edit the local Jenkins file, there we go. I've got all the different stages that I need locally. I do an SBT compile, SBT test, publish local. I do some cleanup of the old containers as well, because these just-in-time UAT is nice, but I don't want 3,000 containers working on my machine, otherwise I don't work anymore. Yeah. And as we said before, I can even decorate the current build description with the container URL, because maybe I can get this URL and give it to the product owner and say, why don't you have a look at what I've done? And you can do the push as well. And you don't have to store your credentials into a Git repo, because you just use the same features that Jenkins has, the ability to just get the credential externally from the vault, okay? If you want, we'll give you as well the URL of the sample project that has been donated by Net-A-Porter Group. They invest a lot in open source, and they decided to give this one to the community as well. And the central pipeline does other stuff. The still built, because you never know, maybe the dependencies are not there yet, and there could be some other reasons, but I don't have to run all the testing again, because I ran already locally. And I can do just the deployment to Heroku. There we go.
And again, as you can see, the steps that we are running on the two pipeline are totally different. So for example, the central pipeline does deploy to Heroku whenever the branch is master, which is something that, of course, the local pipeline does.
Yeah. Local pipeline doesn't do that. Okay, so it's not black magic. So we didn't invent, I don't know, how to go to Mars, but it's a very simple trick that allowed those guys to go from hours of cycle time. I'm talking about hours of a single feature. And from you implement the feature until you show it to the product owner say, yeah, that's good to go. And then you can go and deploy to the target environment. Okay, and that's exactly how it works, right?
Yeah, this is what we showed you before in the demo. Again, the just-in-time UAT, as I said, is one of my favorite feature, in particular when you're working on a front-end application, because you need to tweak around a lot with JavaScript. You might need to change slightly the color rather than moving a button from here to there. So sometimes you really want to sit down with the product owner and just say, okay, just tell me where do I need to put this button. And this way you can have an environment up and running in a super fast way with your feature that you are working on.
And another thing as well, how many times happens to you that you have a limited set of environments and then you need to say, okay, can I use the environment? No, hold on. We use it for a demo for Mr. Manager XYZ. Then you say, the next deployment window is within 20 minutes. And then you say, yeah, but there is a queue. We've got 10 features to show to the product owners, so please wait. In this way, as the local pipelines we run in different local laptops, so basically the product owner, whenever he wants, he has some URLs, can go to the URLs. You don't need to queue for any environment. It's there. And that's the last one. So you say, okay, Luca, but you didn't show me exactly how you managed to have different Jenkins server definition. So that's the trick. So we basically brought the concept of a pipeline in the source code one step forward. They say, let's not just put the definition of the pipeline. Let's put the definition of the whole thing. So the entire Jenkins server is defined into the source code. It seems crazy, but if you really know how Docker works, it's not that difficult, because you don't leave to the developers to reinvent the wheel. You create a base image that is a prototype of the local pipeline. And then what the different projects need to say is just, okay, so I want just a prototype of the local pipeline, but I want plugins ABC. And this is what you say in your source code, okay? And that actually works, absolutely works. Okay, so Q&A. So first of all, we wanted to remind that this was not a kind of out of the blue imagination, or I don't know, we just had some dough, but we thought about doing this. We did this by looking at the data. So extracting the data from all different systems, from Jira to the code review to the commits. So we were seeing, for instance, when the developers start producing the commits and when they get the first feedback from the CI, and the build time, and the queuing for the target deployment. And we put everything together. We graphed that data. We saw, oh my gosh, yeah, we need to make the build faster, but that's not the whole point. The whole point is to just shorten the feedback to the product owner. So that was our solution, but absolutely every company is different. So we wanted to give the word to you guys. So do you have the same problem? Yeah, absolutely. That's Q&A. Okay, so that's a very good point. So at this moment, we were in a situation where it was kind of simple. It's just Linux, just a web app. There we go. It's simple. If you have multiple platforms, you still have the ability to have those platforms somewhere in the cloud, for instance. You can have some Windows on the cloud. You can have even some remote Android simulations environment on the cloud. There are the guys from Source Labs. They provide environments on the cloud. And you can basically pool them. So the developers basically are using still their local pipeline, and the pipeline is Jenkins, but they're controlling some remote resources. And those ones are in a pool. So you could say, guys, your team has a pool, I don't know, of 10, 15, or 20 machines. That's it. And from your local pipelines, you're getting, let's say, those machines remotely. You control them remotely. And whenever you don't use it anymore, you shut it down. We had some similar situation here because we got so excited about the local pipelines, so we said, why don't we do the integration test as well from the local pipeline? We just did it. We did it exactly in this way. We asked the business to allocate this. For instance, in our case, we needed to integrate with the WebSphere Commerce Server. And WebSphere Commerce Server, unfortunately, is available just in a very limited set of platforms and requires so much memory that I can't run on my laptop. So we had some shared environment, but they were in a pool that we could reuse from our local pipelines. We were just pointed to them. One is that, okay, take the second one. Second one is that, take a third one. And Jenkins helps you out a lot because in your local pipeline can put the logic of the retry as well. We say, okay, this environment is done, let's take another one. But the good thing is that you can control everything from your local pipeline.
But that pool that you created,
yep.
really have a central control. I would then potentially have agents from every one of the developers inadvertently picking one of the pool resources.
Not exactly. It depends on how you allocate, how do you define the pool. Because whenever you have a pool, you can do the allocation by, let's say, reservation as well. So if you get one, it's not going to give you to the other one. Yeah, it has to be exclusive. Otherwise, the fact of being repeatable is gone. Yeah, absolutely. What we were doing as well, when we were even getting, because it's different team that gives you this pool. When we were getting the instance, we were doing some kind of health check on the instance before running the set of tests. We were saying, listen, if the health check is telling me that this environment looks really shit, let's get the next one. Yep.
So how are you handling getting credentials to your developers so their local pipeline can actually do things like check out code or push artifacts or any of those things?
Yeah, thank you for the question. So first of all, we have seen that the local pipeline was getting the changes immediately. How we did that? So it's very simple. So we basically connected directly the local Docker container to my .git directory locally. So it's not doing a remote connection to pick up the commit. It picks up the commits directly from my local system because it's a local pipeline. So I don't need to put any credentials because it's just accessing from my local file system. And nobody can access because it's just local. I can see it, the other people can't see it. That's the first point. The second point, when I need to push to the second system, okay, yeah, I need credentials, right? And for doing that, basically, we reuse the concept of the keychain in Jenkins. I can show you here, for instance. So if we go to the local pipeline, here, there we go. So if you see the definition of this guy, the passwords are not defined here. Sorry, build configuration. Okay, in this case, just for doing the fetch was not doing it. Let's look in it was in the pipeline definition. So if you go to local Jenkinsfile, there we go. It was not hard coded. Yeah, it's getting with a credential ID. This one is not entered manually, right? But when you spin up the local pipeline, it gets basically a template of the local pipeline, and enrich the template with the local credentials that are going to be injected on the fly locally. So when you start the local pipeline, you put the credentials. And those ones gets injected into your local pipeline and go into the Jenkins vault. They're never in clear text. And if he runs his local pipeline, he will get his credentials automatically.
And these are the only credentials that you need, because the credential, for example, to deploy to a Heroku in this case, they will be just stored in the central pipeline. So you don't need the single developer to have access to the Heroku credential, for example.
Okay. Just to repeat the question was, how can I make sure that I'm able then to push to the server automatically? Do I have to hardcode the credentials somewhere in my Git repo or whatever? No, the answer was no. You can get it automatically injected from the template into your local pipeline. Yeah, another question? Okay, that's a very interesting question. Let's repeat the question. The question is, where is the boundary between the support of those Jenkins instances? Do you allow the developer to do everything? Do you give support by other people and so on? I believe the answer is very simple with the word DevOps. There is no difference anymore between, let's say, who is developing and who is doing any sort of operations. Basically, there is a complete melting of the two concepts. So those guys, I think they've got more skills than the ops guys.
Yeah, it's also true that I think it really depends on the company mentality and the period of time. Because as I said before, we've been in a transition time in our company where we had two different cultures in terms of development and operation. So we needed to find a kind of in-between solution. And yes, we have a centralized DevOps team, which we collaborate with, and they take care of what we call the central pipeline. But the nice thing is that, so we kind of trust each other and we collaborate between each other. So we had the chance of like maintaining our local pipeline ourselves. So it's kind of a collaboration. And we think that is a nice trade-off because we don't step on each other's feet.
Sorry, can you just repeat the question again? Yep. Okay, yeah, it's a good point. So this is actually a point on when you trigger. So first of all, it doesn't make any network calls. So the question was, how do you trigger the build when you make changes locally? So do you do a scan of the local environment all the time and so on? Do you generate an overload for that? So first of all is a local Git access, right? So it's not calling anything on the network, it's not calling any server workload, it's really super fast. And the second thing is that as there is no Git server, because everything is your local machine, you can easily configure that specific pipeline even to check every minute, okay? You can say, okay, check my local file system every minute. And it's not very expensive for Git, because at the end of the day, the only thing that needs to do, it just needs to go and check what is the SHA of that specific branch, or all the branches that are there. And typically, you don't keep 2 million branches locally. I hope so, right? Oh, yeah, that's a good point. Yeah, thank you for your contribution. So his suggestion is, why don't you just do a Git hook locally, and whenever you do a commit, you just go and call the recipe out. Yeah, well done, well spotted. Thank you very much for sharing. Okay, so I'm sorry, but I have another talk exactly in 5 minutes. If you want to know more from those guys, so this is where we are. So if you go to the exposition hall, we're just in the corner of CloudBees. The name is Garrett Forge. Come and talk to him. We'll tell you what they've done. And if you're interested in the next talk, I'm going to talk about Jenkins Forever. And it's going to be in 10 minutes. Okay? Thank you very much for coming, guys.
Thank you.
And very appreciate your time.